The UFO's perimeter is precisely traced onto the floor, guided by meticulous measurements. Steel rods are subsequently cut, bent, and welded together, forming a rigid framework that serves as the foundational mold structure. Soil is spread over the area where the UFO's outline was marked. Guided by the structural tool, the soil is shaped to form the cabin of the vessel, creating a mold into which the mortar will be poured.
Once the mortar has cured and hardened, a release agent is applied. The result is a solid negative mold that serves as the foundation for constructing the cabin of the UFO-shaped watercraft.
Fiberglass chopped strand mat is laid over the negative mold, and a liquid polymer resin is applied on top, which then hardens and bonds the fiberglass layers together. A supporting structure is assembled using metal bars to hold the UFO-shaped watercraft in position. The frame is designed to provide stability and access during the next stages of construction. The outer structure of the cabin is built by applying fiberglass chopped strand mat and polymer resin directly onto the supporting frame. Using the same method, additional structural components and support elements are created, serving as essential parts for the ongoing assembly. The negative mold is carefully separated and removed from the outer cabin structure. Then the edges of the fiberglass shell are trimmed and smoothed to remove any roughness. Finally, the entire surface is sanded to achieve a clean, even finish. Hexagonal shapes are cut from drywall boards according to the design specifications of the UFO-shaped cabin, serving as molds for the window openings. Next, rectangular-shaped molds are mounted onto the dome of the watercraft to create openings for natural light. At the end, the mold for the entryway opening is mounted, providing structural support and defining the shape of the entry point. Hexagonal patterns are formed on the interior surface using fiberglass chopped strand mat and polymer resin, creating a geometric design. This process creates a strong, lightweight interior that improves both the aesthetics and structural integrity. The lower section of the watercraft is built using the same methods and steps as the upper cabin, with the exception of the dome shape. If you're still watching and enjoying the project, don't forget to give it a thumbs up and subscribe. It's the easiest way to support the channel.
The keel is crafted and mounted onto the lower section of the vessel. It helps reduce sideways drift caused by wind or currents, ensuring smoother and more efficient navigation. All gaps and seams are reinforced with fiberglass chopped strand mat and polymer resin to create a watertight structure. Then, any excess material is trimmed and removed. The propulsion system is installed on the keel of the watercraft and secured with additional supports. Rubber bushings within these supports dampen suspension vibrations, preventing movement and keeping the assembly securely in place. The propulsion system is assembled starting with the jet propulsion unit, which draws water in through an intake and expels it at high velocity through a nozzle to generate thrust. A drive shaft is then connected from the jet drive unit to the engine, transmitting rotational force to power the system. After an additional cutout is made for the intake grate, the lower part of the watercraft is coated with a black protective layer to enhance the hull's durability and longevity during operation in the water. The essential part of the construction is completed. The structural skeleton of the UFO-shaped watercraft is now assembled, including the upper and lower sections, the keel, and the propulsion system. The moldings for the entrance and window openings are removed, and the edges of all cutouts are then trimmed and smoothed to eliminate any roughness or irregularities left from the molding process. This step prepares the openings for the installation of doors, windows, and other finishing components, which will complete the form and functionality of the watercraft's cabin. The exhaust system is assembled, including the installation of a water box, which serves as a muffler. The water box mixes cooling water with hot exhaust gases, reducing both temperature and noise before expulsion. The hose is placed over the fitting, ensuring it is fully seated. Hoses and clamps are then used to securely connect the water box to the exhaust manifold and pipe. The system injects cooling water into the exhaust line, lowering gas temperature before discharge. The exhaust system provides noise reduction, engine protection, cooling, and back pressure regulation. A smaller pipe is installed for the steering linkage, connecting the handlebars to the steering nozzle. As the handlebars turn,
The nozzle pivots left or right, directing the high-pressure water stream to steer the watercraft. The steering linkage is routed through designated holes in the watercraft's body and aligned with the internal structure, then securely connected to the steering handle.
This setup transmits the handle's movements directly to the steering nozzle at the rear of the watercraft.
After the edges of the openings are smoothed and adjusted for a proper fit, the driver's seat is securely mounted in its designated position inside the cabin. The engine case is constructed using drywall boards covered with fiberglass chopped strand mat and polymer resin, resulting in a lightweight, corrosion-resisting structure ideal for marine environments. The painting process begins with the interior area of the watercraft. Multiple even coats of paint are applied to ensure even coverage. Then, the exterior surface is sprayed with the final coat of marine-grade paint, providing long-lasting protection against harsh marine conditions. The entrance door is fabricated using the same materials as the watercraft's body. After it is shaped, a protective coat is applied, followed by a layer of plaster to smooth out any surface imperfections. For added durability, the door is then reinforced with an additional layer of fiberglass and polymer resin. The door is divided into two separate parts to allow for easier access and improved functionality. After cutting, any excess material is trimmed and all edges are smoothed to ensure a clean fit and safe handling. An open and close mechanism is crafted using metal bars, heavy-duty screws, and electric tools.
The metal bars are cut, shaped, and assembled to create hinges and support arms that enable smooth movement of the door sections.
The mechanism consists of two main parts: the stationary section, which remains fixed, and the moving sections, which enable the door to open and close using screws and bolts. The moving bars, functioning as hinges, are securely connected to the stationary part of the mechanism.